Hey, ladies and gentlemen, we're going to have a look at question number 14. It's an achievement check question in section 7.4. I am not going to read the whole problem to you this time, but it does say that we're dealing with a sample of 300 tomatoes that has 92% acceptable standard, so I guess that will be the mean of our sample. Let's see now, so what's the confidence interval for the load if the confidence level is 95%? So if the confidence level is 95%, that means that we're going to use a Z of 1.96. That should be familiar to most of you because we had a couple of examples like that in our class in the lesson 7.4. So what we're going to do to find in order to find the confidence interval, we first must calculate the error. So the error formula is Z times the square root of P times 1 minus P divided by N, the sample size. So we're going to plug in 1.96 times the square root of, see now it's 0.92, 92%, times an 8% chance that you don't get an acceptable tomato, divided by a sample size of 300. And when you work that out, you should get something along the lines of 3.1%. Now, in order to find the confidence interval, we're going to subtract that and add it from and to the mean of 92%. So basically we're going to do 0.92 minus 0.031 at the low end, 92% plus 3.1 at the high end, and that works out to 88.9% to 95.1%. Or another way of saying it would be 92 plus or minus 3.1%. Okay, so that's part A. Now for part B, we need to convert that to tons. So basically 88.9% of 41.992 tons. All the way up to a high end of 0.951 times, oops, it should be 41.992, and those work out to 37.33 to 39.93 tons. For part C, we have to convert each of those tons to $94.40. So we're going to take 37.33 tons times 94.40, all the way up to a high end of 39.93 tons times 94.40. And when you work that out, it comes out to a whopping $3,524, up to an top of the interval being $3,769. You could round that to the nearest 10 or to the nearest 100, because we don't know it to 4 significant digits. So I'm just going to say, about 35. Oh, I don't know, 35, 20. I think we have 3 significant digits to $37.70 is our confidence interval in terms of cost or value. And so for part D, load is acceptable as long as the sample contains at least 67% acceptable tomatoes. So that's That's the low end. The actual sample was 92%. How does this range of values change for a load at this level? I'm not sure what they mean by values. So, well, first we'll figure out what the percentages would be. So we'll start all over again now. Just to show that we're starting all over again. Maybe I'll do it in red. There we go. This is a whole new problem. That's better. So now we're going to do E is equal to, again, 1.96. It's still a 95% confidence interval. But now we're going to do the square root of 0.67 times its complement, which is 0.33, divided by a sample size of 300. And that works out to a significantly higher margin of error. It's 5.3%. So that works out to, if you subtract it or add it from the 67, you end up with 61.7% to 72.3% for the confidence interval. But we could record that either as a percent or as a number of tons or as a value. So if we multiply it by the number of tons and by the value, you end up with 2446 to 2866, or if I use 3 significant digits, 2450. Was that 24? Oops. 2450 up to a high of $2870. So that's the interval, but so is this. Or of course we could express the confidence interval using tons. I hope that helps. I'll see you in class. Thanks.